Hi everyone! Today we're going to continue talking about ways we can find the zeros of quadratic equations. Just a reminder, zero is just another word for your x-intercepts. So what we're doing with these equations is solving for x. Now, anytime you're given a trinomial, your goal is to get it into its factored form. So you can use the zero product property and set each factor equal to 0 and solve for x. Let's go ahead and try to factor this quadratic equation. So factoring is just reverse boiling. So whatever's in your first spots has to multiply to be 3x squared, which is just 3x and x. Then our last terms have to multiply to be -5, and our outers and inners have to add to be 13x. So let's just try something. Let's say it's -5 and plus 1. So our first terms and our last terms work, but our outers are going to multiply to be -15x. Our inners are going to multiply to be 1x. And that's going to add to -14x, so this isn't going to work. Okay, let's try rearranging and see if we can come up with something else. I'll just try, I don't know, changing the signs. Our outers are now going to be 15x. Our inners are going to be -1x. That adds to 14x, so still not going to give us 13x. And let's try rearranging again and say this time our outers are going to be 3x. Our inners are going to be -5x. That's still not going to add to 13x. And you can try all day long, but hopefully you've kind of realized by following along that this particular quadratic is not going to factor as nicely as we had hoped. So before you might have just given me a sad face, can't factor. But what we're going to do in this video is discuss an alternative way to solve for zeros or x-intercepts if you can't factor or possibly can't complete the square of that particular quadratic. And the good news is that this method will work no matter what kind of equation you're given. So you can apply this to any quadratic. It may not be the easiest, but it'll work every single time. So you can kind of just use one equation for every situation. And that equation is called the quadratic formula. So the quadratic formula solves for x in any trinomial that's a quadratic. So any ax squared plus bx plus c, where a, b, and c are all numbers, some sort of coefficient, and a can't be 0, because, right, if a were 0, this would just be a linear equation. Okay, so quadratic formula is just x equals the opposite of b, and I say opposite because let's say you plug in -2 for b, your opposite of b would be +2. Okay, so it's not just negative b, it's the opposite of b. Plus or minus the square root of b squared minus 4 times your a times your c all over 2a. Okay, so you're just going to apply this formula to each coefficient of your quadratic. So let's look at this example. You have ax squared plus bx plus c equals 0, so we can use the quadratic formula. In this case, your a is 3, your b is 13, and your c is -5. Okay. So looking at the notes you wrote down for what the quadratic formula is, hint, hint, write down notes, you can just plug in all of these coefficients and solve for your x value or your x-intercepts. So let's go ahead and do that. So our first part of our equation is we take opposite of b. So if this case the b is positive, now it's going to be negative. Okay, then you have plus or minus your square root of b squared, which is 13 squared, minus 4, the 4 is always there, times a, times c, which is negative, all over 2a. Okay, and this equation you just kind of have to know and memorize, so I'm going to post a video with a song that may help you remember this. Please watch that at some point. We'll probably watch it in class a few times as well. Anyways, now you just have to simplify this equation. So we have -13 that can't be simplified right now, plus or minus the square root of, well, what's 13 squared? That's 169. And now you're going to subtract 4 times 3 times -5. So keep in mind you're multiplying a negative times a negative, so that'll give you a positive. 4 times 5 is 20, times 3 is going to be 60. All over 2a, which is 2 times 3, which is 6. And we can keep going. So our -13 still stays. Our square root simplified will give us 229 all over 6. Now you want to use your simplifying radical skills that you learned at the beginning of this year to simplify out the square root of 229 if you can. In this particular case, if you try and factor tree that out, you'll notice 229 is prime and you cannot simplify this radical anymore. So lucky for us, we don't have as many steps in this problem. But if you can simplify the radical in these problems, you always should. In this case, since it doesn't simplify, I can just rewrite my solutions as my final answer. So let's look at this plus or minus for a second. What does plus or minus mean? It means that the equation could be negative 13 plus the square root of 229, or it could also be negative 13 minus the square root of 229. So one of our solutions is negative 13 plus the square root of 229 over 6. And our other solution is negative 13 minus the square root of 229 over 6. Okay, so sometimes when you're solving for x, you will have two x-intercepts. As you can see from a parabola, that looks something like this, right? It's going to cross 2 times based on the fact that we have two x-intercepts. Now you'll see why this one didn't factor is because these x-intercepts are really ugly fractions, and the quadratic formula was the best method to solve this particular equation. Okay, so please make sure you have the quadratic formula in your notes. I just want to point out a couple things that may happen. You could have two solutions. The other thing that could happen is that, let's say, I don't know, and once again, this is not related to the problem above. Let's say it was something like this, negative square root of 229. Keep in mind what happens when you have a negative under the radical. And this is our connection to that imaginary numbers piece we talked about for a couple days, is that anytime you have a negative under the radical, you're going to have imaginary solutions. I'm not going to give you another full quadratic formula to complete and look at, but let's just say you completed the quadratic formula and you got the solutions were negative 2 plus or minus the square root of, let's say, negative 32 all over 4. You always want to try and see if you can simplify this radical. So let's go ahead and do that over here. If you have the square root of negative 32, it's really like the square root of negative 1 times 32, which we can split into two individual radicals. So we have the square root of negative 1 times the square root of 32. And from our conversation about imaginary numbers, the square root of negative 1 we can rewrite as I, and 32 we can try and factor tree out. So this is 16 times 2, and this is 4 times 4. Okay, I see a group of 2. 1 comes out, and the 2 is left under the radical. Now, to put this in proper form, I would say this simplifies to be 4i root 2. So x, if I rewrite this, is equal to negative 2 plus or minus 4i root 2 over 4, which you can split to see that it has two solutions. Even though they're imaginary solutions, there's still two of them. One is negative 2 plus 4i root 2 over 4, and one is negative 2 minus 4i root 2 over 4. Although we did not solve the quadratic formula again, I just wanted you to get an idea of what would happen if you had a negative number under this radical and how you would simplify that. Okay, so these are your two solutions, but they are two imaginary solutions. What I want you to do right now is to pause this video and apply the quadratic formula to all three of these equations. Okay, it's going to be good practice for the quadratic formula, but also it's going to segue us into our next topic, which there's going to be a second video on. So solve all of these, see what you get, and then we're going to discuss what you see here in terms of the x-intercepts in our second video. Okay, so finish these problems up, and then you can go ahead and watch our second video. Don't forget it. They're both equally important towards your knowledge of finding zeros. Okay, so good luck with your solving, and I will see you in the next video. Bye-bye.